close. He was in a philosopher's group of friends, and they all left Germany. He decided to take his life because he didn't want to be caught by the Germans. And no one else in that group committed suicide. But it was a false rumor, and everyone else lived their lives. But now they have a gigantic commemorative stone that rises up that commemorates him because he died in his 40s, and yet he had so much more to give to the world as far as his ideas of life. And one of them was craft. And what really struck me, there was one thing that just popped out at me. And I had forgotten about it until about 2.5 years ago. I thought, wait a minute. This is what Lumel is becoming, or has become. What he talked about the trade routes from the beginning of human travel, and how crafters were always the stopping point along the trade routes, because you would drop off wares, you would buy wares, and he felt that craft was storytelling, providing news, information, sharing together, and then moving onwards. And then that information gets disseminated into the community through the craft institution. And I think about what we do here and how we try to grow community, and how there's so many stories here that affect others, and sometimes every time you tell a story, it will resonate. And a simple story that is really poignant is that a couple from San Francisco came through, and this is a place where people talk, and they said she had been diagnosed with terminal cancer. So they decided to sell everything, get into their motorhome, and only turn left. If they couldn't go down the road with their motorhome, they didn't go down the road. But they would go to the end, and then they would turn around, and they'd come back, and they'd turn left again. And they figured for as long as she lived, they would travel all around the Americas by only turning left. And I've told that story to multiple people, including a huge tourism event in Vancouver. And there was a massive sigh from the gathering in this grand hall, because stories like that are important to all of us. And the science of passion, of listening, that story might be told by anyone in the crowd and passed on. But yeah, providing a place where their stories can be told, so they go out.
And it's because that touching story always makes you think that this is what sounds like also an art performance. That is what someone who's an artist would take away and only to react. Oh, what they have it. And it shows that when everything is important to you, it's time to say like what would be important to you. Creativity all the time. And if there is one big case of intersection between art and science, it's creativity. When people talk about like sometimes they can believe in faith, but you have an intuition. Obviously in science you are going to always prove it. But that doesn't mean that you have to prove before you have to punch. That is the way that but she arrived here.
Yeah, and they kept going. They wouldn't have come back through Whitehorse because they would have gone over through Perron and around because only turning left. And so sometimes you never, even in the north, you cannot retrace your footsteps if you're always turning left. Now, do you want to jump in and talk about the recycling initiative?
Boy, now it's going to get real boring. No. So the glass that we use is art glass, and I think you probably noticed, but it's about 70% sand, about 15% soda ash, because the sand has a very high melting point, so they add soda ash to basically lower the melting point, but then to increase the durability, they add limestone or calcium carbonate. So that's art glass, and we know how it works. It's very predictable. We know how to anneal it, and it just is easy to work with. We're in a teaching studio, so this allows people to work with glass longer without having to always be reheating. With post-consumer waste glass, bottles, pickle jars, you don't really know what it's been made of, because if Dick's wants to buy 1 million jars to put pickles in, all they care about is that it won't break too easily and that it's really cheap. That's all they want, right? And it's food safe. So when you start to take post-consumer waste glass and put it together, you run into some very interesting, and there's people in the room here who would be able to tell you the science of it, with why it isn't all compatible. But it becomes a real challenge, and it becomes stiff to work with, and it's kind of hard to work with. And our artists here have done it. Luann's worked quite a lot with recycled glass, but it's not something that we would use in the studio in general public. So we started working with Raven Recenter on how we could use more of the glass that's here. Because just in Whitehorse alone, for deposit glass, so beer bottles, wine bottles, and whatnot, there are about 400 tons of glass a year that the government pays a deposit back on when you take it to Raven. 300 tons of that ends up in the landfill because it's not economic to crush it and send it south to be recycled, because part of this, a lot of this glass is actually recycled glass as well when companies do that. But it's not economic, so breweries buy a few bottles and they do actually sell some of the glass self, but it's not a very economic deal. So we started talking about how to use it, and as we reached out to contacts that we have, we found out that there are many people actually that are using it, studying it, trying it, and we heard one name pop up all the time, and it's a guy by the name of Christian Thornton. He's an American who's down in Mexico, and everyone was saying, oh, you've got to talk to Christian because he's been doing this for years. So, to make a long story short,
contacted him over and over and over and over again, and he never got back to us. So finally, we just told him we were traveling, coming down, and we were going to visit him.
So at first, I mean, a lot of people probably try to contact him because his name floats around. And at first, he was kind of not overly willing to sit down and talk. But we did end up having a chat with him, and we told him where we are, and we told him about the challenge that Yukon has. We're not alone, by the way. Newfoundland is a long way from recycling as well, and other places. And we told him about the studio, and what we do as a community. And he agreed right away to come into a commercial agreement with us, which was very fair, to use a recipe and a process that he's developed. So that's we were able to acquire that, what it is, there's a lot of science to it. There's no magic. You don't have to put bat wings in or anything. But it's things like lithium that you add, and more soda ash, and there are some other fundamental elements that you add that basically creates a situation where the glass is now compatible and usable, and it's got a working melting point. We saw it work in Mexico. Then the next challenge was, okay, where do you buy lithium? On the street, and other chemicals, some of which are controlled chemicals. So controlled like sodium nitrate is very difficult to acquire. Anyway, we jumped through a bunch of groups and found out a way to acquire all this. And we have a process efficient that we are starting to work with.
Unfortunately, though, you guys know this now. You know that on a given day you can have hundreds of people in here. And so the time for both of us now to develop this more is just not there for us because we're running Lumel Studios. So we want to do a lot more with the recipe, but Raven is saving for us.
Yeah, so the deal between Raven and us, the memorandum of understanding is they will collect the glass and clean it and crush it. That's the hard part. Throwing in a few things and using a process that's a bit different and using that furnace there, it's called a Phoenix, to work with it, that's the easy part. And like Lou says, when we get the time here in the next short while, we'll start using it. We have some of the glass prepared that we received from Raven. Now, how much do we use? Ideally, instead of importing this glass from the Czech Republic, we would use all recycled glass. But we're also looking for other things. And I'll just say one more thing about community interaction. So we travel with our baby dragon, our portable furnace, and we were up in Dawson and we were talking to the community, and of course a lot of plaster miners in Dawson, and they were very interested in this. One of the plaster miners said, well, why don't we build our own furnaces, melt all the glass, make trinkets, and let the tourists take our glass out of the territory. Kind of is what we're talking about doing. But anyway, the other thing that came up was there was somebody there saying, well, we plan on making a greenhouse out of bottles. We're going to just take bottles and we're going to cement them together because glass is a very good insulator and it's got a light that goes through it and whatnot. And we said, well, what if you took 10 times the volume of bottles, crushed them up, and if we melted them into brims? They said, we'd buy them right away. We already have a couple people who have said, you do that, we'll buy the brims. And there is a business that does that. But that's something we can do. And there are many other ideas. Lou and I are not going to build a brick building factory or a bottle making factory at our stage of life. We're pretty busy here. But our idea is to show proof of concept, and there's an engineer in town who said very interested in using it for engineered fill. It's sand, I mean, it's what it is. So we said we'll show proof of concept. We'll show what the economic model looks like, this much input and this kind of market, and then find entrepreneurs, young entrepreneurs or older entrepreneurs, that will take that to the next level. So that's where we're going with recycled glass.
Raven has the property to build a facility like North
there's a company in Newfoundland called Newfound Sand, and they bought a machine that basically you can put bottles in and it creates very fine sand. The machines happen to be made in New Zealand. We saw a thing on CBC. I contacted the company in New Zealand, and they've got different models. But what Newfoundland is doing is selling that sand to golf courses, because golf courses are having a shortage of market to find sand. So anyway, there's things that can be done.
We have Natalie, another instructor of mine here. Natalie, you want to begin here our beginning where you can ask? I don't know if I can, but I will try.
I think the thing about glass that often is overlooked, and I think Mel and Lou are thinking about it, is that it is a resource that can be used over and over and over again. It's not something that will change or degrade. You can always put more additives in it and keep using it. I think bottle, now don't quote me on this, because sometimes I make up figures. I've got a lot of superpowers, and one of them is the gift of storytelling. But I think you can reuse a bottle something like 25 to 30 times before it degrades enough that you have to re-blow it or reuse it. And so it's a material that, when it breaks down, ends up as sand. It's a material that doesn't change our environment in the same way as, say, plastics do. And so, in terms of a material that is incredibly carbon inefficient in terms of making it, the longevity of it is unbelievable. So there's a famous vase that is in the British Museum called the Perron vase. It is a Roman vase that was found in its entirety. And the opening night, I think it was at maybe in Cambridge, maybe it was in Oxford, the Ashmolean, and it was on a cliff, and a drunk young underground grabbed into and broke it. So here's a piece of glass that has lasted over 2,000 years in the earth that has come to us via time travel, only to be wrecked by a young student, which I feel like I have a lot of experience with at the Alberta University of the Arts. But the point is that the only thing that will stop glass from being cool is flex. So it's got the same kind of compression capacity as concrete. So as a building material, it's really useful. The only thing that wrecks it is when it can flex. That's it. And so, when Lou was telling me about what this talk was about, I was thinking about the natural intersection between art and science, because I don't think they're very far apart. It takes a flight of fancy to be able to understand, and now I'm quoting from one of my favorite comic books. When you look at a bird's wing, you can see the pharaohs, right? You can see the physics of it. What we do is the same side, it's opposite sides of the same. And without understanding the flights of fancy that happen in the sciences, or the deep, deep, pragmatic approach to the material that we as makers have to approach, I think we lose something in the discussion as well. I have to agree, because when I was always thinking of Corning, it would be fabulous if you had glass industry at the same thing they have to do that. That was the combination that they thought, and because they love one another. There is something like the one who developed the fiber optic industry. When they go, the glass museum there is a glass wall. It's a glass wall for glass. So it's a little bit like a photography. When you like your white box for photography, where you have this perfect diffuse light, because there's nothing more difficult than putting light on glass. So because of that, they decide, okay, the whole museum is the light box. All the objects, you don't need the light on it. But you can see that therefore that industry in Corningware and maybe in fiber optic, and it's enormous industry. It's small, it's small in place. employed and the Glass Museum is the two making. So the recycling idea are really, and Walter Benjamin says the storytelling is by planting it in more people's heads. That then we all dream that something. So you talk to everybody, you know that when you know suddenly it happens. So like that, it takes that.
At our studio, we just had every grade 8 student from St. Francis come in 4 different groups. And we talk science with them and they create. And there's so many things. I say different things to every class that comes. Oh, we had a great kindergarten class from Ames Junction that came just this week on Monday, and they were talking about the states of matter, liquids, solids, and gases. And so that's what their focus was as they were creating on our bench. 2 artists per person because they're 5 years old, but they were still working with the states of matter that they were talking about. A number of years ago, we had a professor from McGill come, and he was visiting family up here, and he asked us to make a cylinder, and you can Google this, it is online, and he asked for us to put a small blackish tube in the center. Glass magnifies, so we ended up just getting an elongated black piece of frit, and we put it in, and the tube is about 3 inches in diameter, and it's a solid sphere of glass with this black thing inside. What that is brown paperweight. This one. Inside is nuclear waste. It's a piece of a rod that they need to encapsulate to make sure for all eternity that it will not disperse. They make these and then they bury them just over a mile deep and make sure that wind, water, that there's no erosion that can possibly destroy that cylinder of solid glass. So your paperweights that you make here, I always say don't
Don't make it reduce.
and keep everything else safe by packing them away from any other object you created. When that home in Riverdale exploded and the homes across the street, the doors, windows, walls were blowing out, we had 2 families that came in here to tell us that their ornaments that were hanging in their windows, one was 25 feet across the yard, the others, their whole front
requires craft and this sort of body knowledge to make it possible. So, you know, I think the great thing that Lou does here is around that notion of a body, right? Allowing people to come in, 5-year-olds, have this moment with a bright light and some fire, and learn about the states of material. And then the other thing that happens here is that, you know, when we talk about glass as a material, both artistic and non-artistic, is that when we're looking at it, because it's transparent, we're not looking at the skin of the object. So if we look at the concrete or if we look at the upholstery on the bench, we just see the surface of it. But when we look at the glass ball or the rod with a little bit of cement that you put in, we're looking at the interstices. So it also becomes a sort of material that allows us to play with magnification, with refraction, with the distortion of light. There's all of these things that we can do with it, but it also becomes this fundamentally sort of philosophical material that for us at the art school becomes such a rich tool for investigation.
And you, I think the community knows, we do a lot of action here now. And it is one of the sweetest moments when we're in sometimes such horrendous sorrow when you have gathered up the ash and then you bring a hot log of glass that floats down over the ashes to taste them. And the sight of that is stardust. It is the Milky Way. We're organic creatures. We all gas. Even our ashes do. There's small little areas where the glass can't flow into. And so you take those small little protrusions and you take the off-gassing and you get minute bubbles associated with every tiny piece of ash. And that's stardust. And I love it when kids are here and they brought their puppy dog in and we're creating things together. And you can say we're just all stardust. Like the materials that we're working with are all out there. They're all out here. And so we're all stardust. That's science, but that is so real when you talk about it.
The fascination when you see glass artists representing embodiment. I also think that we are at a time where we're returning. Obviously, if you are a structural engineer, but you need to return to love and a knowledge of our material. It's been dematerialized to a large level. You know, like where we live more virtually than inside our. So me, I love that. A 5-year-old could become a scientist simply because he's falling in love with materiality. Like the deep knowledge of materiality. But I always find it more difficult when teenagers find glass fibers. Impressing teenager is way harder than 5 years old.
Yeah.
You know? So in my mind, every teenager that passed 3 years would be safe. You know, like the deep fascination is tough. For teenagers, and they all, you know, they have to be glass of that. And it's really from every age.
So, are we close to the end? Because we talked about fiber off the table, so that's how I want to end it. We're going to pull some fiber off the table. But any comments?
Far-ranging conversation.
All the colored glass, is that same composition as we were talking about earlier on with?
Oh, I love this for their high school students too, because I have a shirt that says I wear this shirt periodically, and I'll wear it a lot with high schoolers. But the transitional metals, that rectangle in the middle of the periodic table, like if in high school I could have been here and somebody would have said transitional metals, they taken quartz that holds our gold in the gold fields. It's silica combined with other minerals to create that white hard rock. But it's a transitional metal. We don't have it out. We have a gold ruby. And it's one of the most expensive colors because it has a mineral gold in it, which is a transitional metal. And so when our high school students come, we say, yeah, you can pick a color, but while you create, you have to tell us which transitional metals you are using to create your object. Yeah, and so we have the simple, you keep it simple, the simple diagram out that shows what colors we have and what transitional metals we're using.
What are transitional? But that's the point. This is an improvement.
Oh, it's good. It's good.
That's
Well, have a look. There, yeah. What is it?
It's part of a, I'm not a scientist,
Yeah.
glassblower, so I will try and explain it, but I'm sure that you will have a better explanation. But it's some of the particles that have unusual capacities. So titanium as a metal that we understand it as something that can be put in our bodies and it's neutral. As soon as we start to add it to a hot material like glass, it acts as a colorant.
Yeah, and lithium.
That's as far as it's
So, now mention lithium. We've gone through 4 different glass suppliers since we opened this studio. And you talk about a business of glass. I phoned Seattle, Olympic Color, and they provide our clear glass to us because they are the North American supplier. And it comes up by March, and now went today, drove over the White Pass, picked up to 1 ton of clear glass and color and brought it back over the pass to us. But every time I talk with Mark and Olympic Color I phone him every time, and then I say, Mark, what do you hear lately? What's up there? What should I be aware of? Because Mark knows we live a long, long way away, and that it is not easy for us if supply chains break. And so through Mark's contact, I have usually heard ahead of time that the glasses, the clear glasses faltering, that you might want to buy. At one point, we brought a whole container of glass because one company was going under. But now, our Czech Republic glass has lithium in it, and after I sculpture a lot now, I have increased my muscle capacity in my lower extremities here because the lithium makes this crystal clear glass, but it's a stiffer glass to work with. It holds the heat longer than any other glass we've ever had. So you think that it's cooling, but it isn't. It's just a very, very stiff glass because of the lithium in it. Czechs have been glass blowers for over 1,000 years. They blow clear glass that they want time to blow it. They want it to make huge objects. They want a stiff, clear glass. They put more lithium in than any other glass product that we've bought in the past. So ingredients can affect how the use of things and how they move.
So that's the stiffness of the that's a property that you see something.
For them it is because
Why did you see it?
because that was the next class that we were advised to get. We were buying glass out of Mexico, but it was becoming more haphazard.
furnace went down.
Yeah, so They stopped production. Portland, Oregon, they were putting arsenic into their water supplies. That stopped.
So it's based on supply, not necessarily the properties that
So I want, yeah.
So most of the art class has a set of properties that we all look for. One of it is clarity. And so that's the other thing the lithium does is help
Yes,
clarify the
yeah.
glass.
Yeah.
Because almost every silica source has, or sand source has some kind of copper or iron or some other material in it that will cause the glass to look green or yellow or ambery. So if you think about almost any of the historic glasses, like the beginning Forest and other places, they're all
Depression.
yeah, they're all kind of colored. Cristallo or crystal glass, which is decolorized glass, was invented in the 11th century in Venice. And so we're always looking for decolorized glass so that when we add color, we get the color that we want. And so this glass has an interesting history because the formula is similar to American-made glass that was then exported to the Czech Republic to be made as studio glass. So we want the glass to last a certain amount of time in terms of heat, because the more times you have to go reheat it, the more times you have to go reheat it. So you want to be able to work with the glass as fluidly and as seamlessly as possible. And so every time we change glass masses, we have to relearn how to blow glass almost, because it becomes such an embodied and such a habitual motion that I went from blowing glass similar to this to blowing a glass that was made for a factory. So it was made to go into a mold, stay hot, like keep its form. And I was trying to blow in this North American style with it. And by the time I got back to North America, every time I went to blow glass, I would heat everything up so much that it would all shrink back on itself. Because it's a liquid. So the hotter it is, the less viscous it becomes. The hotter it is, the more centrifuge affects it. And so every time, especially in a production studio like this one, when you change glass, you have to learn the timings of everything, and your entire team has to learn it. And when you have people, anyway, it becomes a challenge.
And everyone down south is just talking, oh, it's the clearest glass. Such incredible glass to use. All of you probably know that our knockoff bin, where there's color in it off of your pipes, because you dip into the color a little farther, there's color in our knockoff bin and a lot of clear. That knockoff bin goes right back in the very same day. So we pollute our glass constantly. And so we're not out for the clarity of glass. We're out, let's see how we can celebrate it on the bench. Let's see how we can really use it. Let's see how we can reuse it and reuse it and reuse it. And so it's really interesting getting the glass that is known for its clarity or its clearness at Lumel Studios, when that is not one of our main mandates to make this pristine glass. And all of our glass has bubbles in it, and we will get people, tourists from Japan in, and we know right away to walk over to them because they're looking at it and you can see they see a bubble. You can see it right away. Now, or somebody from Seattle might see bubbles. And we go over and we say, those bubbles prove that we recycle every single bit of our glass. And we're very proud of that fact that our glass isn't as clear and that we have to feel it.
It's a beautiful rainbow. Like I was thinking
But this is fine too for those, yeah, I need to be careful because for any studio that wants the clarity and wants that clear glass, that's fine for them.
Yeah. No. I was just going to say, but that's one of the beautiful things about a studio that is so far from the center is that, I think embracing glass as a material in all of its funkiness and all of its beauty is as important as someone who's making a vacation.
find that it can affect the surface, but it will not break the panel.
So is that like marble?
Yeah.
Exactly what we played with as
Yeah.
kids.
Yes, yes,
Yeah.
yes.
The different, so marbles are also, I don't know if you've talked about this, but there's annealing ovens. So once you've blown the glass, you have to cool it at a very specific rate because as Mel said earlier, it's weight insulator. And if you have more than 5 degrees difference in the volume of glass that you're cooling, you introduce strain. And so this paperweight won't break because it has been well annealed. Well annealed, it's been well cooled. So
So if you just make that and put it on the table, it would hold its shape, but eventually it would
it
balloon
would create.
and explode.
And
So why don't we have glass, clear glass or a window that is thicker instead of a insulating bag?
it would be, it's because of the way the glass is made. So window glass, if you imagine a big giant furnace that's tipped a little bit, that's pouring hot glass onto a lake of tin. And as the lake of tin, and then it gets pulled across the surface of that lake of tin, there's big burrs on the top of it, and then it gets pulled, that strip of glass gets pulled into an annealing furnace that's 2 kilometers long. So by the time it reaches the end of that 2 kilometers, it's at room temperature. And so that process, like they can make glass up to 3/4 of an inch fairly easily. But the thing that insulates better is the air gap in our windows.
That's why we're really flying up here.
Yeah, and so that's the balance. Yeah.
Yes.
Yeah, the gap. And sometimes that gap is filled with liquid gases to give it even a better insulation quality.
You were talking about Corningware. When did it first come out?
Sheila knows. Sheila wins a trivia name.
There's a related piece that what happened was it was an accident. It was an accident. There was somebody who was charging the basically making a glass test batch in a furnace, and they forgot to set the temperature, so the furnace just went up and up and up and up and up.
I haven't everything out.
Cooked it completely, so then when the next morning when they went in to take the glass out, it was like this cheese or cheese, kind of. And when they found, they said, it's garbage, we gotta get rid of it. Started pulling it out and realizing that it was just bouncing on the floor. And nothing would crack it. It was like this amazing thing that happened, really by accident. And so they took that accident and made money.
Because I was thinking about this Corningware casserole dish my mom had, right? And she had it all my life, and I couldn't think of it. So she might have got it one time I was born. And that it's still in our family, and
It's an amazing thing.
you can't see through it anymore.
No.
But it's still getting
If you think about like vitreous materials, like things that are glass-like, they kind of start at ceramics, like certain kinds of ceramics, and it goes all the way to glass. And so Corningware is closer to the ceramic industry than anything else. But you can blow it.
So all of
Yeah.
that is actually glass.
Yeah.
It's the blue color.
Yes, Corningware.
So how come that people are just shipped off?
Because it's glass.
But you have to work hard.
Yeah. Or not hard, depending if you have both kids. The thing about glass is that every rule that we think applies to glass doesn't. So when I'm teaching people how to blow glass, I have a set of because I've been blowing glass for a while now. I think that I know what's going to happen, and then the students are like, "I'm going to try this." I'm like, "Okay," and they break physics. I'm like, "How did you do that?" There's no way like I know how to do that because they don't have the expectations of the material. They have this beginner's mind.
There was a product in the UK where they used like a foamed glass.
Yeah.
You mentioned bubbles earlier
Yeah.
on, but this was just like an aero bar,
Yeah.
but it was made of glass. But it was a
Yeah.
fantastic insulator
Yeah.
because of all the air in it.
Yeah.
But you could put a 10-meter wall on top of it and it
Yeah.
wouldn't break it.
Yeah.
So they used it as a
Yeah.
like
Because
an
it's also
insulated
round.
barrier.
So there's all these like perfectly round little bubbles in the. This is
And
the other
that's why the ornament lasts, this lasts because of the round.
Yeah. So if it's a circle, it spreads the force of the impact on it,
Yeah.
and the arc becomes a really good can handle the weight of the building, right?
Yeah.
That's why they like arcs.
I had made a large black ladder, so I had uneven thick and thin, and it was basically sitting in the window, and the sun came in over half the piece of glass, but the other half was in some shade, and it went crack right down the middle. Just that little area, because there's enough stress in the unevenness of the glass, probably and it caused just that little tiny bit of crack.
There was a famous Canadian glass artist by the name of Jeff Goodman who was hired to make a curtain wall of glass for the high temple in Santiago de Chile. And so each piece of glass, because it was an architectural form, was different from the next piece of glass. But the material testing that they had to go through, they had to find a glass that they could put into a kiln, cast into this sort of curtain-like shape. So it was both a curtain wall and curtain-like. And make sure that it wouldn't break under the most extreme conditions in Santiago de Chile. So they put it into a kiln, took it up to 60 degrees Celsius, took it out of the kiln and put it into something at minus 60. And the borosilicate glass, which is a glass that is very close to it, just silica, it has some other stuff in it, has hardly expansion period as it heats and cools. A lot of the corningware, the clear corningware is that kind of glass as well. And so he had to find out a whole new way of casting glass in a kiln in something that's like a lost wax casting process to be able to build this wall. So he had to be able to bring his kilns up to 2,000 degrees Celsius and whatever the mold material was. So this is where I think that intersection between science and making happens most closely is in these collaborations.
And you talk about the round, like our glasses, you might know that I know the counter. Some of you might have had your glasses banged on the counter. So when new glass artists come here, the glass blowers, Sheila said you gotta make them thicker. Sheila, you gotta make them thicker. They're not a lot thicker, but they're round and they're thicker. And I always say they're hardy like cucumbers. Because we want our glasses used every single day. We want them to last. We want them to last 3 more generations after you. And so we specifically create our glasses in a different way because we're Yukoners. We make our glass Yukoners. But it's the roundness of them, and then we add a little more thickness so they're extra strong glasses.
All of that was the thing that humanity is inventing new material. We are in a time where new material are invented a lot. You know, like when we think what time period we are. And I was thinking of Mireille here. When you were saying like the foam in the glass, which I didn't know anything about. I have to go and check it out. You see, it's a fabulous sign for inventing new material as we speak.
For new usage for
And for
material.
new usage to solve a lot of our problems. Insulation, stupid energies. You know?
Yeah, I remember working in Cwmbran in Wales, and they used glass, and they would just spin it,
Yeah.
and you get rock wool out of it
Yeah.
for insulation. So
Yeah.
that was a fascinating
Yeah.
job.
Yeah. And the Australians
Rock wool.
fiberglass. And in Australia, the studio glass movement started with the pellets that make that they would put it in the furnace and blow it, because that was the glass they could get. Before I forget, you also have a question.
I just had a quick question. Do you guys do any lampshades for silicon glass since it came up?
We do, no, but we have Tommy in Canada, who is staying. But during the conference, that tent out there is going to have the flame workers, the torch workers, and especially on Friday. There's not many on Saturday, but on Friday, and
There on Friday, there's a couple from Quebec, and they're actually really famous.
Super famous.
Yes,
and they're in the Yukon.
and they make them. And he, there's a wife husband team, and he was trained as a technical glassworks.
Scientist.
Yeah, he was the guy who released things. And they are fabulous. They are at.
So if you can take your lunch breaks, you're working at 1 o'clock, hop over.
Sorry,
1 o'clock on Friday.
Although there's a lantern group at 5.
Oh, yeah.
Yes.
Yeah.
Awesome. So,
A big eye maker? Like a glass eye maker?
The glass eye.
Yeah. Here's the thing that all glassblowers get super excited about, because there's some mythic creatures out there in the world that make eyes that people can put in their heads. I don't know.
They must compete with the watchmakers.
I think maybe I remember when I said never trust people's numbers. This is one of these ones.
Yeah, and we know, and there's a fair number of people that have contacted us to say they haven't shown up. Yeah. And we're doing it the Italians when we have the World Conference, that we're doing it the Italian way. And we are sure doing it the Yukon way. And we even got some Yukon cold weather to play with. So that's too bad. Cold weather. Make sure people know that. What I'd like to do is pull a fiber optic cable. Who wants to run? No.
I can stand there and be cheering.
I know Stanley taught us this as students.
Yeah.
We have Mass Olympics.
Which are hilarious.
Yeah. But we do this with every class, every RV group that comes to our studio, seniors from Copper Ridge, creating the fiber optic cable. Or we'll do a volcano thing. Explode. Is everyone ready?
Pretty much, Dan.
So, this is what we found with the Bowman glass out of the Czech Republic. We would make it maybe just to the street if we were really, really lucky. Whereas, with Bowman glass, and the stiffness and how it retains the heat, I even have to back up and Mel has to stop.
Yeah.
So, if you look on the road, it is here. Mel's